Continuing on with our final exam review, we're going to move to number 11. It says the distribution of heights of adult men is approximately normal. The distribution has a mean of 69 inches and a standard deviation of 2 inches. Bob's height has a z-score of negative 0.5 when compared to all adult men. Which of the following statements is true? So we're dealing with approximately normal distribution. The mean in the middle is 69. Standard deviation is 2. So we can fill in up and down a standard deviation. Now Bob's height has a z-score of negative 0.5. So because it's negative, Bob is shorter than 69 inches tall. If the z-score is negative, value is below the mean. If the z-score is positive, it's above the mean. If the z-score is 0, it is the mean. B says Bob's height is half a standard deviation below the mean. That is also true. By definition, the z-score is how many standard deviations a value is either above or below the mean. So because the z-score is negative 0.5, it is half or 0.5 of a standard deviation, and it's below the mean because it's negative. Which means Bob must also be 68 inches tall. The answer here is all of the above. Since the standard deviation is 2, half of 2 is 1, so he would be 1 inch below the mean. Since the mean is 69, 1 inch below that would be 68. All of these are true. Number 12 says in a statistical hypothesis test, we say the data are statistically significant at level alpha if. When do we say the data are statistically significant? That goes back to chapter 8 and chapter 9. To me, one of the most important things in the class, if the p-value is less than your alpha, you reject HO and the data are statistically significant to conclude the idea of your alternative. Alpha is typically 0.05, but it doesn't have to be. Alpha is small. Well, alpha doesn't really come from our calculations. We can't really worry about alpha being small or large. It's when the p-value is less than alpha. Now, when the p-value is larger than alpha, you do not reject HO and the data are not statistically significant. Number 13, based on a 95% confidence interval of 20% to 26%, what is the margin of error for this estimate? Well, p hat would be 23%. That's right in the middle of these two. If you add those together and divide by 2, that gives me my estimator. And then I can see the margin of error has to be choice C, 3 percentage points. If you take 23% and subtract 3, it would give you this 20% on the lower end. If you take 23 and add 3, it would give you this 26% on the upper end. Number 14 says we might use data to answer the question, do more than half of all adults agree with this statement? Which of the following will be the null hypothesis? That is your HO. Recall that null is always equal to, so it has to be choice B. We want to know, do more than half, well, half is 50% or 0.50 or 0.5. So that's our baseline. The alternative, by the way, if we needed to find it, HA would be P is greater than 0.50. The phrase is more than half, so more than 50%. Here we're just asked to find the null. 15, 16, and 17 are going to come from this situation. It says a large company produces diabetes medications. The company claims that American workers lose an average of $30 in wages or pay each month. Now this isn't from a sample. This average is from all Americans, so this is my mu. It's an assertion about the population. It's a population mean. A consumer advocacy group is a group that tries to make sure that everyday people aren't being ripped off, they're not being tricked into buying things they don't need. The consumer advocacy group doesn't believe the diabetes company It thinks the company just wants to sell more medication. That the average isn't really $30. They're saying, oh, you need to spend $30 a month, but it's really less than that. The advocacy group studies this problem, analyzes it statistically. They take a random sample of 100 American workers. They found that these 100 people lost an average of $28 a month with a standard deviation of 950. First step, what are the null and alternative hypotheses? The answer here is choice C. My baseline is $30 set by the company, so mu is equal to 0.30, or sorry, equal to just 30, not 0.30. The alternative mu is less than 30. We don't think it's $30, but we think it's somewhere less than that. Now this is a hypothesis test, and we're focused on the average. We're focused on the mean. So this is a hypothesis test for means, which is important on the next page. Number 16, what is the p-value for this significance test? So to find my p-value, we've always gone to the calculator. It'll be stat test. Number 2, the t-test. This is a hypothesis test for means, for averages. We're talking about mu's. So like this. I don't have the raw data. I have the statistics. My mu, my baseline was $30 from the company. My x bar was 28. That's my sample mean. The standard deviation was 950 from a sample size of 100 American workers, and our alternative symbol was the less than symbol. That's what we had in choice C. When you hit calculate, your p-value is 0.0189. These choices take it to 2 places. So the closest answer would be choice D. It is 0.02. At a 5% significance level, what would you conclude for this study? Well, my p-value is less than my significance level. It's less than my alpha. 0.02 is less than 0.05. When that's the case, you reject HO. So I would reject the claim of the company. I mark out B, I mark out D. We do not support the claim of the company. Instead, we reject the company. We reject HO. And the data are statistically significant to conclude the idea of HA. So we think the monthly salary loss because of diabetes is less than $30. HA didn't have anything to do with 28, but HA was that mu was less than $30. Number 18 is also going to require us to use the calculator. We have a random sample of 100 students with a mean GPA of 3.2, a standard deviation of 0.2. What is our 95% confidence interval for the mean GPA? So this is a confidence interval about means. To calculate, I'm going to go to stat test number 8. This is a chapter 9 problem. Confidence intervals and hypothesis test about means are from chapter 9. When we're dealing with means, we use the t interval. So I'll select number 8. Again, I have the stats this time. My x bar, my sample mean is a 3.2. My sample standard deviation is 0.2. My sample size happens to still be 100, and I'll leave my confidence level at 0.95. When I calculate this, my confidence interval is exactly choice B, a 3.16 to a 3.24, because the 9 rounds that 3 up to a 4. Number 19, researchers took a random sample of 500 adults from a population of over 1 million adults. Researchers wanted to compute a confidence interval for the mean. What could the researchers do to decrease the width of the confidence interval? That is, make it narrower and more precise. If you decrease the width, you make it narrower, you make it more precise. How do we do that? A says you decrease the size of the population. Well, you can't change the size of the population. The population is set. You can't add people or objects or take away people or objects from the population. Population is set. Same with C. I can't increase the size of the population because it's the population. I can, however, change the size of the sample. B says to decrease it. D says to increase it. When given the chance, you always want to increase the size of the sample. That will make your confidence interval narrower and more precise. We discussed that back in Chapter 7 and in Chapter 9. Last question for this video comes from Chapter 4. I want to match these scatter plots with the R values with the correlations below. So number 1, there's no correlation between A and B. R is 0. Remember that when R is 0.75 and above, we said it was strong in our class. When R is 0.50 to 0.74, we said it's moderate. And when R is 0.49 and below, we said it was weak. So 0 is as weak as you can go. This one's scattered all over the place. This will be scatter plot A. There is no pattern here. It's very weak correlation. 2 says there's a perfect correlation. R is positive 1. It's as strong as it can be. There is no scatter at all, and that's what we see in scatter plot D. So number 2 matches with scatter plot D. We have a positive correlation going up here. 3 is a perfect correlation between A and B, but R is negative 1, so it's headed down with no scatter. That would be F. So I've matched A, D, and F. I've got 3 scatter plots left and 3 R values. I've got negative 0.80, positive 0.80, and positive 0.6 or 0.60. If I look at the remaining 3, scatter plot B has a positive trend, it's going up. Scatter plot E is a positive trend, but scatter plot C is a negative trend, it's headed down from left to right, so number 4 matches with scatter plot C. Out of the 2 remaining scatter plots, B and E, the R value of 0.80 on number 5 has to go with B, and the R value of 0.60 has to go with scatter plot E. Here the dots are a little bit more clustered, they're closer together, so it's a little bit stronger, so that's why it goes with 0.80, the strong correlation. On scatter plot E, there's a little bit more scattered, so we would say it's a moderate relationship here. And this goes back to Chapter 4. So that wraps up these practice problems. This isn't the end-all be-all for the final exam. This is just a good idea of the topics you can expect to see on the final exam. I would recommend you go back and you study your old tests. You can view those in Canvas by clicking on your grade in the gradebook. Look at those multiple choice. Go through these review problems that we've gone through in these videos as well. Go through the review sheet when I specifically narrow down the topics for the final. If it's on that review sheet, it's on the final exam. If it's not on that review sheet, it is not on the final exam.